Hi, everybody. Hope everybody's doing well. Today, what we're going to do is start off where we left off. I'm sharing my whiteboard with you, and hopefully you'll be able to see what I'm writing. We're going to go back and talk about the same material as in the previous class just to get everybody started again, and then the next few videos will be on newer topics. So to start out, what we need to discuss is what exactly is a mole. And so remember that 1 mole of things is equal to 6.02 times 10 to the 23rd things. 6.02 times 10 to the 23rd is sometimes referred to as Avogadro's number. We use a mole in chemistry similar to we would use a dozen in everyday life. It tells us how many things are in a collection. We need a lot of things in a mole so that we can actually see them, since atoms and molecules are so small. So if we were talking about a mole, I could say that 1 mole of sodium would be equal to 6.02 times 10 to the 23rd sodium atoms. If I was talking about 1 mole of water, I could say that 1 mole of water would be 6.02 times 10 to the 23rd water molecules. And if I was talking about sodium chloride, I could say that 1 mole of sodium chloride would be 6.02 times 10 to the 23rd sodium chloride formula units. Now, I know one thing that confuses people is the difference between sodium atoms, molecules, and formula units. You use atoms when you have a monatomic element. You use molecules for compounds and for diatomic elements, and use formula units for ionic compounds. So sometimes people are confused when we're calling things atoms, molecules, or formula units, and it really just depends on how they exist. Most elements exist as singular atoms, so when we talk about a mole of them, we're talking about atoms. All covalent compounds exist as molecules, and all ionic compounds exist in the units called formula units. So that's one thing to keep in mind as we go along. So the second definitions that you need to know is, what is a formula mass? Formula mass is the mass of a formula, and you get a formula mass by taking the sum of the atomic masses of all atoms in a formula. The unit for a formula mass is usually in atomic mass units, which are abbreviated in AMUs. Formula masses are not really all that helpful because we can't really see individual atoms or molecules or formula units. So what's more helpful to us is a molar mass. And the molar mass is the mass of 1 mole of a substance. When you're trying to find a molar mass, you really need the formula mass to do this, because a molar mass in numbers, numerically, is equal to the formula mass, but it is expressed in the unit of grams. So this is equal to the formula mass expressed in grams. So these are 2 definitions. One, if you're going to forget, is formula mass, but do not forget molar mass, because we're going to need it extensively. So first, let's just do a couple of sample calculations. First calculation, what's the molar mass of carbon tetrafluoride? Carbon tetrachloride is a covalent compound, so it's going to exist in units of molecules. To find it, we need our periodic table, and we know that our formula has 1 carbon in it, and the atomic mass of carbon is 12.0. And then we have 4 chlorines, and on the periodic table, our atomic mass of chlorine is 35.5. I only went out to the tenths. If you want to go out to the hundredths, that's fine. It just depends on how many sig figs you need. So 12 and 35.5 times 4, 142. So my total is 154.0. I could say that 1 molecule of CCl4 is equal to or equivalent to 154 AMUs of carbon tetrachloride, or more useful, I could say 1 mole of CCl4 is equal to 154.0 grams of CCl4. Whoops. So this one is our molar mass, and this one is really going to be the one that is most useful to us. So once you have a molar mass, what it allows you to do is calculate between mass and the number of things. Remember, we can't count the number of things because we can't see them. So our only way to really know how many things are there is to go through this unit of a mole. So here are a couple other problems that we can work on. So we now know that 1 mole of carbon tetrachloride is equivalent to 154 grams of carbon tetrachloride. We can do 2 types of problems with this. I could ask you, problem 1, what is the mass of 0.452 moles of carbon tetrachloride? If you had to do this problem, you're going to use this as our equivalent statement, and this just becomes a conversion problem. Remember, an equivalent statement can be written as a conversion factor. So as in all conversion problems, you start with what's given first. So here is our given. So our given is 0.452 moles of carbon tetrachloride, and we're going to multiply that by a conversion factor. If I want to get rid of the unit of moles, I'm going to put moles on the bottom of my conversion factor. So 1 mole is going to be 154.0 grams. Moles of carbon tetrachloride will cancel, and my answer will be 69.608, given by my calculator. Remember to look at sig figs. So we have 3 sig figs here. So I only want to have 3 sig figs here. So I'm going to change this to 69.6 and then have my units, grams of carbon tetrachloride. This would be my answer for the problem to the right number of significant figures. Another type of problem we could do is how many moles of carbon tetrachloride are in 57.44 grams of carbon tetrachloride. Again, this is a conversion problem, and this time our given is in grams. So our given being in grams, 57.44 grams of carbon tetrachloride. In my conversion factor, I'm not going to put moles on the bottom, I'm going to put grams on the bottom. Now grams of carbon tetrachloride will cancel out. Now my calculator, I'm going to get 3.729870013. You got to again watch out for sig figs. 57.44 is 4 sig figs. Our conversion factor is to 4 sig figs, so we're going to keep this to 4 sig figs. Now when we drop off that 8, I have to round up the 9, and so the 9 is going to round up to 10, which is going to change my answer to be 0.3730. Remember to keep that final 0, 4 sig figs. My unit's going to be mole carbon tetrachloride. As we get going, some of the problems are going to get a little bit more involved in this. This mole to gram or gram to mole calculation, though, is very fundamental, and this is one you should practice in the homework. So other types of problems you should have to do would look like this. How many carbon tetrachloride molecules are in 0.67 moles? How many CCl4 molecules are in 0.67 moles of carbon tetrachloride? Now, if we were to do this problem, we're never using the unit of mass. We don't have grams in there. We're going from molecules to moles. So although people get really happy with doing this molar mass calculation, this problem does not really require a molar mass because there is not the unit of grams in there. To solve this problem, we have to go back to our definition of a mole. We know that 1 mole of carbon tetrachloride is 6.02 times 10 to the 23rd carbon tetrachloride molecules. This is now going to be used as our equivalent statement to solve our problem. Our given 0.67 moles carbon tetrachloride. We want to get rid of the unit of moles, so I'm going to put 1 mole on the bottom. I'm going to put the number of molecules on the top. Moles will cancel, and if I take 0.67 times 6.02 times 10 to the 23rd, and I maintain only 2 sig figs, because this is only 2 sig figs, my answer should be 4.0 times 10 to the 23rd carbon tetrachloride molecules. If this question wasn't a covalent compound, but was something ionic like sodium chloride, we wouldn't be using molecules, we would be using the term formula units. So what if I make it a little bit longer? What if I ask you how many molecules are in 95 grams of carbon tetrachloride? Now this problem has the unit of grams in it, and whenever you see grams and number of things, you need to use a molar mass. So this problem is going to require 2 steps. We're going to need the molar mass, which tells us that 1 mole carbon tetrachloride is 154 grams of carbon tetrachloride, and the relationship that 1 mole of carbon tetrachloride is 6.02 times 10 to the 23rd carbon tetrachloride molecules. We need to know both of these relationships. 95 grams is our given, so we're going to start there. I need to get rid of grams, and the only one that has grams in it in my equivalent statements is the first one. So using that one to get rid of grams, I'm going to have 154 grams of carbon tetrachloride on the bottom, 1 mole on the top. Grams will be gone. I'm now in the unit of moles, and I want to get to molecules. So now I'm going to use my second equivalent statement in order to do that. I know also that 1 mole of carbon tetrachloride is 6.02 times 10 to the 23rd molecules. So I'm going to go 95 divided by 154 times 6.02 times 10 to the 23rd, and I believe to 2 sig figs, you should get 3.7 times 10 to the 23rd carbon tetrachloride molecules. So these are 2 of the types of problems that you should be able to do. We can go a little bit further, and if we go one more step, we have to add in another relationship that we haven't talked about yet. So what if I asked you this question? 6. How many chlorine atoms are in 8.5 times 10 to the 10th carbon tetrachloride molecules? Now to do this problem, I don't have moles and I don't have grams. All I really need to know is how many atoms are in a molecule. To find the relationship between how many atoms in a molecule, all you need to do is look at the molecular formula. This formula tells us that in 1 molecule, the CCl4, we have 4 chlorine atoms. I'm just reading the subscript of the formula. That's the only equivalent statement we need to solve this problem. Our given is 8.5 times 10 to the 10 carbon tetrachloride molecules. I want to get rid of carbon tetrachloride molecules, so I'm going to put 1 molecule on the bottom. Has 4 chlorine atoms on the top. I just need to go 8.5 times 4. 8.5 times 4 is going to be, I did not calculate 8.5 times 4. So you can calculate that yourself. Again, remember to go to 4 sig figs. Last problem I wanted to do with you is a little bit longer. How many chlorine atoms are in 75.5 grams of carbon tetrachloride? Now this one's going to take all of the steps combined together. We need to know how to get rid of grams. And remember, the only way to get rid of grams is to use a molar mass. So we're going to need to use that 1 mole of carbon tetrachloride is 154 grams. Its molar mass. Also, since we're going to atoms, we know the relationship between molecules and atoms from the previous problem. So we're probably going to have to go from grams of carbon tetrachloride to moles of carbon tetrachloride, and then from moles of carbon tetrachloride to molecules of carbon tetrachloride, and then finally use that one molecule of carbon tetrachloride has 4 chlorine atoms. So this is going to be a 3-step conversion, and again, you always start with your given. So our given is 75.5 grams. And so I'm going to use 1 mole. It's 154.0 grams. How did I know to start with this one? It's the only equivalent statement that had grams in it, and I started with grams, so I have to get rid of them. So now grams of carbon tetrachloride are gone. I now have moles. My second conversion or equivalent statement has moles in it, and I want to put moles on the bottom so that they will cancel. Now moles of carbon tetrachloride will cancel. And finally, I can use my third one that tells me that one CCl4 molecule has in it 4 chlorine atoms to get to my answer. Now, just like in the previous problem, I happen to start recording without having my calculator with me, so I'm not exactly sure what the answer is, but you should multiply 75.5 by 6.02 times 10 to the 23rd times 4, then divide by 154, and your answer, remember, to 3 sig figs, and your units will be in chlorine atoms. So give it a try and see what you get. I'll post the answer and give you some other practice problems in the homework set. You can use these as sample problems to model all your work after, in addition to the ones we did in class before we finished. That's it for now. See you in the next video.